Hello everyone. Welcome to the video on protein simulation. This is the assignment of AS658, that is molecular simulation. So in this video, I will discuss the process, key concept, and steps that are involved during the simulation process. So yeah, let's get started. At first, we have been given the list of protein. From that, we have to select one protein and do its simulation. So we will write Python code for that, so that it will randomly select one protein from the given list. So yeah, so let's write a Python code in Google Colab. Um, so for that, let's import random as RP. So it will pick randomly one protein name and display as an output. And let's give the list of the protein which will be stored in names. So I have already written the name of the protein. So I'll just copy it from the notepad and directly paste on the list. So after that, uh, I will select the write a code to select the name of a protein from the list. So yeah, so I have given the name as protein underscore name, and the AI will automatically write the uh, next code which is needed. So yeah, let's run the code and let's see what the protein name it will give. And after that, we'll start a simulation. So we have been given the protein name called 6R2G. So we'll download its PDB file and start the simulation. So after selecting the protein, we will go to protein data bank. So we will go to browser and type rcsb.org. So it's a protein data bank from where we can download a PDB file of our protein. So we'll type 6R2G protein, which has been selected previously. So we will download its PDB file and save it to the folder which we have created. So we have created a folder named A1 where we will store all our file which are required for the simulation. So after downloading the file, we will need other three files, that is minimize.conf, npt.conf file, and parameter file. So we will download that from OneDrive, which has been shared by our professor. So let's download the file. So after completion of the download, we'll move the file to the folder which we have created. All four files are there. So we are just renaming it for our convenience. So changing it to minimize.conf and pt.conf, and we'll extract this zip file here over here, and we will move all the content from this file to here. So we'll delete this parameter file and this zip file as well. So now we'll open a terminal and open a VMD software which is used for visualizing visualization of protein molecules. So We are seeing our current directory and changing it to A1, and let's open VMD and let's load the protein molecule over there. Our protein molecule name is 6R2G, so we'll write the command and the VMD will load automatically this file. So yeah, so we can see the structure of protein which we have loaded. So this file, but this file contains not only protein but also other substances like water, ligands, and other things. So uh, we have to clean that. But at first, let's change its visual representation. So we'll create a rep and we'll name it protein, and we'll change the coloring method to secondary structure and drawing method to new cartoon. So after double clicking the previous upper file, it will be removed and we will be able to see the protein structure. So this is the protein structure which we have downloaded. So let's change its name to protein. So yeah, so that's something wrong. So let's change this name to protein and let's remove the upper portion. So yeah, we can clearly see the protein structure. It's secondary structure like beta sheets and two helix. So after that, we have to clean this file and only get the protein. So we'll go to the extension and TK console and give the command as set cell bracket atom select and top protein. So it will only select the protein from this file. So it will only select the protein part. Once we have selected, we will create a new file named r1.pdb and we save the file. So the command for that is dollar cell write pdb r1.pdb. So something wrong. So we have written wrong code. So let's write again. So the correct code is dollar cell write pdb r1.pdb. So yeah, uh, we have successfully created a new file named r1.pdb. So let's delete all the existing file and let's load the new file again, which gives the pdb structure that we have just created. So yeah, we have successfully loaded the new pdb file. So let's clear the TK console. Sorry, the code is only clear, so let's clear the TK console. So after that, the pdb file which we have created contains only coordinate, but we requires other information such as angle present, dihedral information, and all those things. So for that, we'll have to create PSF file. So in VMD there is a automatic PSF builder. So we just have to load our PSF PDB file and it will automatically generate the PSF file. So for that we have to go to extension modeling and automatic PSF builder. So after that, let's load the input file. So the molecule is r1.pdb which we have created. Uh, so let's at first load the input file. So we have loaded, and after that we have to just guess and split chain using current section. We have to select that. After that we have to create chains, and finally we have to select apply patches and finish PSF/PDB button. So yeah, our structure is completed and we have successfully generated a PSF file as well. So let's close the PSF builder. After that, let's delete all the file which are present, and let's load new file which we have generated, that is R1 PSF file and R1 PDB file. So the command to load the new file is write mol and new their file name and dot PSF for for loading PSF file, and for loading PDB file just write mol add file name dot PDB. So our file has been loaded successfully. So, but uh, our file has been loaded. So we can see that in VMD, the file which we have generated uh, has to mimic the real experiment. For us, a real experiment is in a real experiment, proteins are mostly experimented with water using water. So in order to mimic that real situation, we use water padding. So for that, we have to go to extension, and there is a add solvation box. After that, we load our PSF and PDB file, and we give the size of box, that is box padding, to 20 angstrom. So we'll give minimum 10 and maximum value 30, so that our water padding will be of 20 angstrom. So after giving the value, we have to click on solve it. So we can see that it's running on TK console. So yeah, it is completed. And we can see on VMD that we have successfully created a water padding of 20 angstrom around our protein. So after that, we again delete all the existing files which are present and load the new file that we have generated, that is solve it. So for that, we go to extension and TK console, and let's delete all the existing file and load again. After loading the file, we want to know the charge of our system. To do the experiment, our system should be neutral. So let's check the charge of our system. So for that, we select protein and water. And we came to know that our protein contains charge. So we have to neutralize that. So for that, we add ions on our system so that it will be neutral. So we are selecting our solvent file, and we are making the final concentration as 0.5, which is mentioned in our question on assignment. So let's ionize our system. So let's so it's processing. So yeah, we have successfully neutralized our system. So let's check whether there contains any charge or not. So let's add the file at first, that is ionized.psf and ionized.pdb file. After that, we'll select our system and check the charge of our system. So as you can see, the charge is in the range of 10 to the power minus 6, which is very less, so we can neglect that. So now we are ready to perform molecular dynamic simulation. So now, as we are ready to perform molecular simulation, we'll not close our PMD, rather than we'll open a terminal and we just before starting the simulation, we have to edit some of the things in minimization file. So we just edit the file. We have to give its path so that it can access the data or the parameters that are required from our folder. After that, we at first we'll give the path to the parameters. So path we have obtained from Ticker console, and we just copy it from there, and we just have to paste over here. We have to change the center coordinates as well. So that also we get from TK console, and we just copy and paste it over here. And we also need vector coordinates. So that is also provided by TK console as well. So we just have to copy it and paste it over here. So why do we need to do minimization? Is the main reason to do minimization is that when we prepare our system for simulation, they may contain bad contacts where atoms may be too close or overlap, leading to the unrealistic force. So the minimization correct this issue before we proceed to more complex situations like simulations like NPT or NVT. So after completion of the edit, now we will run the simulation or minimization process. The command is namd2 minimize.conf greater than minimize.log. So minimize.log will produce an output file which we are much more interested in. So yeah, we have successfully completed the minimization part, and now let's see what we'll get the output. I think we have typed something wrong, so let's correct that. Let's see where we went wrong. So yeah, we have typed minimize spelling wrong. So let's correct that. we'll use MI and MI to see the output file. So yeah, you can see the result. This is obtained from the minimization file. So to get the detailed information, we type the command less and minimize dot log, that which is the output file, and we can get every information which we are interested in. So let's do that once again. That uh, generating output part. So yeah, we can see that we have successfully completed the minimization part. So let's see all the information are present or not. So yeah, we can see every information which are required is computed here. So now we'll move to NPT simulation. So let's open, and for this also we have to edit some values like path and other number of steps. So the command is same. So let's change the path. So the process is same as before. So we'll just copy from the TK console and paste it over here. We don't have the information about the last parameter, so we'll just remove that. We will change the number of steps to 2000 and run our simulation. So we save the file. After that, we run the simulation, NPT simulation. So opening a new terminal and typing the same command as usual, namely to file name, that is the npt.conf greater than npt.log. So npt.log gives the output file where it contains all the necessary information like pressure, number of steps that it executed, and other things. So yeah, let's see. Pressure, volume, angle, boundary, everything is given energy. So let's see the detailed information. So yeah, we can see that we have successfully executed NPT simulation, which is the requirement. So thank you.